All right, so the first one that I'm going to work with you is problem number, oh, it'll open. All right, so the first one I'm going to work with you is problem number 4. So I want you to turn to problem 4, or go to problem 4. 1, 2, and 3 you should be able to do. 4 was a little bit different though. It was one of those interest problems. All right, for number 4, it says, how much money invested at 5% compounded continuously for 3 years will yield $820? So we're going to use the equation A is equal to PERT. That's the equation that we use when it is compounded continuously. You can do this on your own.
Oh, okay.
I'm just working the ones I thought you might have some issues with.
Okay.
All right, remember P is your initial principal. We don't know how much that initial principal is. E is your natural base. R is your annual interest rate. So it said our annual interest rate was 5%. So that is 0.05 as a decimal. And then A is the amount after T years. So A is the amount. A equals our amount, so $820 after T years, and it said for 3 years. So I just plug it in my formula there. 820 is equal to P. We don't know what P is. E raised to the 0.05 times 3 power. Well, P is being multiplied by E raised to this power, correct? So I'm going to divide both sides by that. So this cancels out, and I'm left with P is equal to 820 divided by E to the 0.05 times 3. So I go to my calculator. I go here to my calculator, and I type 820 divided by E. You hit second and then LN. LN is to the left of the 4, okay? It's right there. Raised to the 0.05 times 3. So the initial balance that I invested, or that whoever invested, was about $705.78. $705.78. Any questions about that? Yeah, so to get the E, you're going to hit second, and then you see where it says LN, and then that should pull up the E. Try it and make sure. Second's the blue button, and then the LN. It worked? Okay. All right, the next problem I'm going to work with you is problem number 15. Problem 15, we've got log of x plus 9 minus log of x is equal to 3. What did we say we're supposed to do when we're dealing with logarithms and we see that subtraction sign? We're supposed to divide. So I'm going to rewrite this as log of x plus 9 divided by x is equal to 3. If there is not a base here, what's our base understood to be? 10. Right now we have it in the form of log of b a equals e, but we want to put it in this form, b to the e power equals a. So I'm going to write it as 10 to the third power equals x plus 9 over x. Well, what's 10 to the third power? I put that in my calculator and I get 1,000. 1,000 is equal to x plus 9 over x. We're going to cross multiply. So I now have x plus 9 is equal to 1,000x. We want everything to be on one side because we're trying to solve for x. We want that x value of or we can just solve for x this way. We can subtract x. So we're going to have 9 is equal to 999x. So now we will have 9 over 999 equals x. Well, 9 divided by 999 is 0.0090 equals x. Okay, moving on, I'm going to work number 16 with you guys. So that was your correct answer right here. Now I'm going to work number 16. I've got 2 log of 4, and I like to use parentheses, that way I don't get things confused. So 2 log of 4 minus log of 3 plus 2 log of x minus 4 is equal to 0. Alright, this is where you can't forget that if you've got a number in front, you have to move it to the exponent. Okay? Number in front tells me that I move it to the exponent. So I've got log of 4 to the second power minus log of 3 plus log of x squared minus 4 is equal to 0. Subtraction sign tells us to do what? Divide. Four squared is 16. So now I've got log of 16 divided by 3 plus log of x squared minus 4 equal to 0. What's the plus sign tell us to do? Multiply. So I've got log of 16 over 3 times x squared minus 4 is equal to 0. So now we want to move the 4 to the right side. How would I move it to the right side? I would add it. So I've got log of 16 over 3x squared is equal to 4. What's understood to be my base right here? 10. So now I've got 10 to the 4th power is equal to 16 over 3x squared. Well, 10 to the 4th power is 10,000 is equal to 16 over 3x squared. That's being multiplied, right? So I'm going to take 10,000 and divide it by 16 over 3. So 10,000 divided by 16 over 3 gives me 1875 is equal to x squared. Now how would I get x by itself? Square root, and the square root of 1875 is, what are we supposed to round to? 10,000. So 43.3013 is equal to x. All right, the next one I'm going to work with you guys is number 17. And for 17, I've got log of 4x plus 10 is equal to 3. So again, there is no base, so it's an understood 10. 10 raised to the 3rd power is equal to 4x plus 10. 10 raised to the 3rd is 1,000. Is equal to 4x plus 10. And now y'all know how to solve for x. 1,000 minus 10 is 990 is equal to 4x. Divided by 4. They wanted it as a fraction. It gave me a decimal. It gave me 2247.5 is equal to x. And we write it as a decimal, or not a decimal, a fraction. It's 495 over 2 is equal to x. Is that a, yeah. All right, I'm going to work 18 with you. 18, I've got 3 log of 2x is equal to 4. The biggest mistake I see on this problem is sure you take the 3 back, but you got to remember to take the 3 for both 2 and x. We can't just cube the x, we also have to cube the 2. So this becomes log of 2 raised to the 3rd, which is 8x cubed, is equal to 4. So again, we're going to do just like we've done in 17 and 16. We're going to take, say this is to the 10th, or base 10. 10 to the fourth is equal to 8x cubed. Ten raised to the fourth is 10,000 is equal to 8x cubed. Divide by 8. And we get 1250 is equal to x cubed. Now, how would you get x by itself? Cube root. The cube root of 1250 to the nearest 10,000th is going to be 10.7722 is equal to x. Everybody got it? All right. Next one I'm working with you is 19. Basically, the ones that I skipped were some that you could graph or something like that. That way we weren't just looking at graphs all day. So 19, we've got, because you know you guys can just put that straight into Desmos. I've got log of 5x plus log of 14 is equal to 1. The plus sign tells me to do what? Multiply. 5 times 14 is 70. So log of 70x is equal to 1. Now we've got an understood 10. 10 to the first power is 70x. So 10 is equal to 70x. 10 divided by 70 to the nearest hundredth would be 0.14 is equal to x. Alright, I'm also working 20 with you guys. So 20, we've got 4 raised to the 4x is equal to 8. So right now we are in the form of b to the e power is equal to a. Let's switch it to this power so that let's switch it to look like this so that we can solve for x, okay? So we've got log base 4 of 8 is equal to 4x. Log base 4 of 8 is 1.5 is equal to 4x. Divide by 4 and I get 0.375 is equal to x. That as a, no, not as a decimal, I need it as a fraction, is 3/8. All right, 21. How many terms are there in a geometric series 8 plus 40 plus 200 plus ... plus 3,125,000? So how many terms are in this said series? So in order for me to figure that out, I'm using the formula a sub n is equal to a sub 1 times r raised to the n minus 1. Remember, I am going to give you all these formulas tomorrow. So, a sub n is your last term. Our last term in this whole series is that 3,125,000 My first term in this series is 8. How do I figure out what R equals? Any idea? Second term divided by first, right? Second term divided by first. 40 divided by 8 tells me that I've got a common ratio of 5. So I should be multiplying by 5 each time. So let's see. 8 times 5 is 40, times 5 is 200, and so on, okay? So I'm just plugging everything back into this equation right here. So I've got 3,125,000. And guys, I'm going to be honest with you, when I was working this out earlier, I forgot a zero and it messed my problem all up. So it's important to pay attention to that. Times 8, or is equal to 8 times 5 raised to the n minus 1. So I'm going to first divide by 8. 3,125,000 divided by 8 gives me 390,625 raised to the 5n minus 1. So I'm going to take this and rewrite it as a logarithm and set it equal to n minus 1. So alpha window 5, log base 5, 390, or 390,625. I literally just put it in calculator and I got 8 is equal to n minus 1. So 9 is equal to n. So that means that I have 9 terms in that geometric series. Alright, this one kind of threw me for a loop earlier because we've been looking at formulas that had like x minus 1, or we've actually been looking at problems that said like n minus 1. So to figure out what our first term is, we're actually going to have to plug it in for x. Because what formula we're using for 22 is S sub n is equal to a sub 1 times 1 minus r to the n power over 1 minus r. But we got to figure out what that a sub 1 equals, because it doesn't necessarily equal this term right here, because that we're used to seeing it as n minus 1. So what I'm going to do is I'm just going to figure out what a sub n is. I'm just going to plug 6 times 2 raised to the first power. I'm going to plug 1 in for x. So 6 times 2 raised to the first power gives me 12. So a sub 1 is equal to 12. Our n value, they said there were 10 terms. That's at the top of your summation symbol right there. And then our r value is still what's inside parentheses. Our common ratio is 2. So now we're just going to take this information and plug it in for this formula here. So S sub 10 is equal to 12 times 1 minus 2 to the 10th power over 1 minus 2. So I'm plugging it in. 12 times 1 minus 2 raised to the 10th over 1 minus 2. And I've got 12,276. $12,276 is the sum of that geometric series. All right, I'm going to also work 23 with you guys. What's the sum of that geometric series? Again, we're using that same formula. S sub n is equal to a sub 1 times 1 minus r to the n over 1 minus r. So we're going to figure out what a sub 1 is now. 2 times 1/2 to the first power two times 1/2 to the first power. Actually, we're going to plug, because do you see how x is starting with 0 and not 1? We're going to plug 0, so a sub 0 actually. So our answer is 2. That's where it messed us up right here, because we used to seeing a 1. So our first term, that's going to be our first term in this case. Our first term is 2. R, my common ratio, is 1/2. And how many terms I have is 15. And they want us to round to the nearest whole number. So I've got S sub 15 is equal to 2 times 1 minus 15, oh, not 15, 1 minus 1/2 to the 15th power. Over 1 minus 1/2. So I'm going to put that in as it looks. 2 times 1 minus 1/2 raised to the 15th power over 1 minus 1/2. And they have it rounding to the nearest whole number, so I'm going to change it to a decimal. So that fraction as a decimal is very close to which whole number? 4. So I'm going to write equals 4. All right, I'm going to be honest with you. When I worked this problem, I just thought it would be easiest to write out how much she earned and then add it all together, because sometimes it's hard for me to, honestly, it's hard for me to determine which formula to use where, okay? So During Justine's first year, she made $26,000, right? During her second year, she had a 3% raise. So what I'm going to do is I'm going to multiply that by 1.03. So 26,000 times 1.03. So during her second year, she made about $26,780. And now what am I going to do to figure out what she made the third year? Am I going to multiply it by 1.03 again? Yes. So times 1.03. Third year, she made about $27,583.40. Fourth year, she made $28,410.90. And in her fifth year, her final, that we're looking at, she made $29,263.23. They want to know the total earnings during her first 5 years on the job. So what can I do with 26,000 if they want to know the total? What can I do with all 5 of these totals? Add them together. Yeah, 26,000. Yeah. 2678 or 26,780 plus 27,583.40 plus 28,410.90 plus 29,263.23. And it said over 5 years, Justine made $138,000, $138,037.13. Is that an answer choice or close to it? Might have been some of our rounding was a little off, but that's pretty close. Or I might have messed up. I did mess up. There we go. It's 53. I forgot the .40. All right, 25. In June, Corey begins to save money for a video game and TV that he wants to buy in December. He starts with $20. So June, July, August, September, October, November, December. June, I start with $20, or Corey does. Each month, he plans to save 10% more, so we're going to multiply his by 1.10. 20 times 1.10 is $22. In August, he saved $24.20. September, $26.62. October, $29.28. November, $32.21. In December, he made he saved $35.43. So now I'm going to add all of these back to see how much he saved over a total of all of those months. And over those few months, Corey saved $189.74. Number 26. A teacher writes the recursive definition on the board. What is the explicit definition of the geometric sequence? Remember, the explicit definition is written as a sub n is equal to a sub 1 times r raised to the n minus 1. A recursive definition is written as a sub n is equal to a sub 1, and then we've got r times a sub n minus 1, where n is greater than 1 and n equals 1. So if I'm looking at what we were given on 26, I get that a sub 1 is equal to 399, and that r is equal to 4 over 3. So that means that my explicit definition would be a sub n is equal to 399 times 4 over 3 raised to the n minus 1. All right, now I want you to go back and work the few that we didn't. There was 26, and we worked 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we worked about at least half of them. I want you to go back, and that way you can turn it in and get credit for it today, okay?